Hi everybody, I hope all of you are doing great. In today's lecture, we are going to solve a problem called wildcard pattern matching. It is a very important problem in dynamic programming, and this is, you can say, one of the most important problems in the string related DP series, right? Because this kind of question resembles a lot of questions which might be asked in your company interviews, because this question has a lot of variances, right? So let us read this problem and then start the video itself. Before that, if you can please hit the like button and subscribe to the channel, I would really appreciate that. We are so close to 500 subscribers. So yeah. So let's read this problem statement itself. So in this question, they're giving us an input string S and a pattern P. So S and P, two strings are given to you. Implement wildcard pattern matching with support for question mark and star. Okay, so they're talking about some question mark and a star. Let us see what all of these means. So question mark means question mark matches any single character. Star matches any sequence of character including empty sequence. Question mark, a single character. Non-empty, single character, it matches that. Star can match anything, any sequence of character, ABC, AAA, BBB, anything, right? And it can also match an empty string as well. The matching should cover the entire input string, not partial, and you have to tell whether you are able to, whether this pattern P, which is having question mark and stars, is matching to string S itself. I know the question is not very clear right now. Let us go to the board, understand by some examples, right? And then you can say dive into the, you can say, solution for this video itself. So here we are at the board itself, and I have created some examples in order to demonstrate what this question actually says. So I have written in blue, I have written the string S, and in green, I have written the pattern which is given to us. For example, this is the string given to us and this is the pattern given to us. Can I convert this pattern into the string? Let us see. I'll say that let us replace the first question mark with a P. So I'll replace this question mark with a P. Okay. I'll replace this question mark with a Q, because question mark can replace a single character, right? So question mark gets replaced by Q, any character but a single character, right? Question mark gets replaced from R, question mark gets replaced from S. So can you see this? That PQRS, this PQRS is actually the same string which is given to me in the input itself. So can I simply say that this pattern which is given to me can be converted into the input string itself? Yes, definitely I can. So I hope this is clear that question marks are replacing a single character. So answer for this input, this is S and this is pattern. Answer for this input will come out to be true, that yes, it is possible, right? You have to tell me true or false whether it's possible or not. Let's consider this kind of string. PQRS is the string which is given to us and star is the pattern. What did I tell you? Star can replace any sequence of character. So can I simply replace this star from a PQRS? And after replacing the star from a PQRS, this pattern will be actually equal to the input string itself. So we can simply say that this string will also give me true, because this pattern which is given to me after, you can say, manipulating question marks and you can say stars, which whatever are given to me, I'll be able to obtain the given string itself. I hope this is clear to everybody, right? Let's look at this example, very important example. This is the string given to me. This is the pattern given to me. I will say that I will replace this star with an empty string. I will replace this question mark with a A. I will replace this star with an empty string. In the end, what am I getting? Only a A. Am I able to match the input string? Yes, definitely I am. So this input will also give me a correct output. It will tell that yes, it is true. You can convert this pattern into this string itself, or this pattern is representing this string itself, any vice versa, whatever you want, right? I hope this is clear to everybody. I hope you are able to understand what we are doing. Star can be replaced by an empty string or any you can say, or any string. Question mark can be replaced by only a single character. Question marks cannot be empty string. They have to be replaced by a single character. Let us look at this example. So this is the string which is given to me. This is the pattern which is given to me. And yes, my friend, pattern can definitely consist of, you can say, characters as well. So is this pattern able to represent the string? There are no stars, no question mark given to me. And can you see that every character is actually matching with every position? So there is no need to replace anything with anything. This actually pattern is satisfy this string itself. So answer for this test case will also come out to be true. I hope this point is clear to everybody. Now let us look at the next test case. I have made a lot of test case covering different edge cases. I hope this thing is getting clear to you. I hope the question is getting more clear to you as we are moving forward. This is the string which is given to me in the input and this is the pattern. I will say, okay, A is matching with A. A is matching with A. I will keep it as it is. I will replace this star with this triple B. I will replace this star with triple B. And then I'll say that this C is matching with this C. Can you see A? This triple B is, like, you can say, replaced by this star. This C is matched with this C. So can I say that I can of course match C with C? But now the string is empty. And my pattern is having extra question mark, my friend. Oh my god. What is this? I cannot replace question mark with an empty string. I have to place a character here. And if I place any kind of character, will I be able to match this string? No. This means that this pattern is not able to satisfy the given string. The answer for this input will come out to be false. False. Because A star C is able to, you can say, the partial pattern is able to accept the whole string. But if I consider this question mark in the end, there is no character after C. And question mark cannot be replaced by an empty string. So I have to keep a character here. If I place any character here after C, the string will not be able to match the pattern. Hence the answer is false. I hope this is clear. I hope this test case is very clear. It is a very important test case. Let us go down and let's see more, you can say, test case itself. So A, B, C, Q, D. Alright, great test case, great test case. And this is the pattern which is given to me. I will say that yes, A is matching A. So A is fine. A is matching A. A is matching A. That's great. That's great. So A is matching A. This A is A as it is. Star. Okay. Star I will replace, let's say I will replace star with a B. Right. I will replace star with a B. Let's replace star with a B. There are two question marks as well. So this question mark I will replace by C. This question mark I will replace by Q. Here I will write C. Here I will write Q. This D I will keep as it is. Okay. I'm keeping this D as it is. And it is matching as well. Star. There is some extra star with me. I will do what? I will replace the star with an empty string. I cannot replace a question mark with an empty string, but I can definitely replace a star with an empty string. So if I do this, you can definitely see that if star can be replaced by empty string, nothing will come after this, and the thing which we have obtained is actually equal to the string itself. This means that this pattern is satisfying the given string, and the answer for this test case will be true. I hope all of this was clear to you all. I hope you are able to understand what all stuff we have, you can say, focused on here. I have covered different test cases. I hope the problem statement is pretty clear to you all. Pattern and string is given to you. Pattern might contain stars, question marks, or characters. Characters have to be as it is. Stars can be replaced by empty string on any kind of sequence of characters. Question mark can be only replaced by a single type of character. So you have to tell me in the end whether, like, after manipulating the pattern, can you obtain the input string itself, true or false? I hope the problem statement is pretty clear to all of you. Let us try to derive some solution for this and then move forward in the video itself. Now, just like all the problems we have solved in the dynamic programming series, first we are going to get the recursive approach for this problem, because if you are sitting in an interview and you are directly going over tabulation, you are doing the stuff directly, that is wrong, my friend. Interviewer will think that you have actually mucked up the solution. Showing the recursive, you can say, thing to the interviewer, recursive code is actually, you can say, brute force code, right? So showing this actually will tell the interview that you understand the concepts, right? Rather than mugging them up. So let us try to derive some recursive solution for this problem itself. There will definitely be overlapping sub problems. In dynamic programming, you can say that you want to determine the overlapping sub problems, or we can also say that I want to solve the smaller problem first and I will solve many small problems which will ultimately solve a bigger problem for me. We can of course say all this kind of stuff, but let us get right into it. Full focus ke saath dekhna hai. So this is the string given to me in blue. This is the pattern given to me in green. All right. I will always try to target the first characters. I will always try to target the first characters initially. So can this A, you can say, in the pattern, you can say a character is given to me. I have no option but to use this character itself, right? So if I use this particular character, am I able to match the first character of the string? Yes, definitely I am. If I am able to match the first character of the string, tell me. I will call from here. I will call from here. I will make a call from here. And I will call that if both of these two characters are getting matched, this A is consuming this A. From the remaining string S and from the remaining pattern, what is, like, are you able to, is the remaining string able to match the remaining pattern? I hope this is clear to everybody, yes or no? Because if this you can say pattern is able to match this string, if this pattern is able to match this string, I can definitely return true as well. We already know that if this is able to match this string, if this pattern is able to match this string, and A is equal to A, this means that the whole pattern is matching the whole string, definitely. So I have reduced my problem into this smaller problem. Try to reduce your problems to smaller problems. Now this is the string given to you, this is the pattern which is given to you. Okay, all right, let us see. In a way, I can say I am the first character is right now star. I'm only concerned with the first characters of both of them. So right now the first character is star. Star can do what all behaviors? Star can do what all behaviors? Star can say that I can come as empty string, right? Star is saying that I'm coming as empty string. In the first thing, star will say that I'm coming as empty string. So if star is trying to come as an empty string, if star is trying to come as an empty string, what will happen? What will happen? Star is coming as an empty string. Can I say this will actually remain the same? Pattern is still, because star is not getting matched with B right now. A was matching with A. Star is not star is saying that I'll come as empty string right now. Let me try out empty string and let's see what happens. So B, C, Q, D. The string remains as it is, but star is missing now because star has become empty string itself. So now the remaining pattern is question mark, D, and then star. This is the remaining pattern. I hope this is clear to everybody. Yes or no? I hope this is clear. Okay. This is one of the options for this star. This star can do one more thing. This star can say, okay, I'm matching with this B. Let's say I'm matching with this B. So star will do what? I'm matching with this B. So now this B is consumed by star. Remaining string is CQD. And because star is matching with B, star will actually persist right now. Star will actually persist right now because star can be matched with more. Star can represent empty string, star can represent B, star can represent BC, star can represent BCQ. This means that if star has decided to come as empty string, the string will remain as it is, star will be gone. But if star is trying to get matched with someone else, if star is saying that I am getting matched with B, it will consume B and it will look for other people to consume as well. So star will remain here itself. Question mark, D, and then star. I hope this is clear to everybody that star is now remaining as it is right now. Correct? Okay. I hope this is clear. If it's not clear, don't worry. We are moving forward, and as we move forward, you will eventually understand. I complete the whole recursive tree. If you have got the solution, if you are trying a solution or your own, or if you have got a solution, definitely skip to the recursion code. That I say all the time. My videos are a little bit longer because I draw the complete recursive tree itself, right? So let us explore the test cases and let us see what happens next. BCQD. And this question mark D star we are having. This is the string, this is the pattern. That's great. Let's move forward. Let's see what will happen. Question mark can be replaced by B, I can say. Question mark can be replaced by B. So question mark has no choice but to get replaced by B. Because if question mark is not able to replace with B, I'll never be able to match the pattern because I have to kill the first person from the string, as I have to do here as well, right? In this pattern as well, right? So from this question mark D star and BCQD, this question mark is able to do a single call. In this single call, question mark is saying I am getting matched with B. So if question mark is consuming this B, remaining string is CQD. Remaining pattern is D star. Remaining pattern is D star. I hope all of this stuff is clear to everybody. Remaining pattern is this D star. Okay, let's explore this again. So D star we are having. Can you observe one thing? This D is not equal to this C. I am trying to compare the first characters itself. And in this particular case, this D is not equal to this C. And if this is not equal, I will simply say that, my friend, I'll never be able to, this string will never be able to match this pattern because the first characters are not equal. D cannot be replaced with anybody else. D is not a star. D is not a question mark. D has to come as it is. and C is the first character. This means that this pattern will not be able to match this string, and we are going to return a false from here. I hope this is clear. From here as well, question mark is not having any other option but to match with B. So whatever comes after, like whatever answer comes after trying to match the rest of the strings, I'm going to return that itself. I'm going to return false from here itself. I hope this is clear. I hope this is clear. So if star acts as an empty string at this stage of time, if star acts as an empty string, I'll never be able to get the answer. I hope this is clear to all of you. Now we will explore this subtree when star will say that yes, my friend, I will consume B and I will look for other people as well to consume itself, right? So let us look at this particular case now. Now, in this particular case, we can definitely observe that star is still in the first place and C is there in the, if there is star in the first place, we don't care whatever is in the first place of this remaining string itself. Here as well, star will act in two ways. Star will say, let's say I will end here. I will act as an empty string here. Essentially saying that this star was able to replace only B. This is the call when star has added a B in itself, right? This star has consumed a B. Right, that from here this star consumed this B and right now the star is trying to consume C. But first call is that star will say that I'll not consume anything. Let's say I'll come as empty string, right? Let's say I'll come as empty string, essentially saying that I was only able to replace B. So if this star comes out as an empty string, the remaining string will definitely be CQD because C is not getting consumed by this star, and the remaining pattern will be question mark D star. Of course, because star is acting, this particular star is acting as an empty string now, correct? Okay, let us try to explore this particular side. So star C, question mark C, question mark has no option but to match with this C. So question mark will do what? It will call and it will say that, let's say I have to replace myself with C because I have no option. So question mark is saying that I am getting replaced by the C itself. So this C is getting consumed, question mark is getting consumed, remaining pattern and remaining string will be passed as it is here. And again, you can see this kind of case where the first character of this, but the ith character of string S is not equal to the jth character of string P, right? So this pattern will never be able to match this string, because their first characters are not equal. I cannot replace D with anything else because D is neither a question mark nor a star. This means D has to come as it is, and Q I want to match, so I'll not be able to match. I'm going to return a false from here, and this has no option but to return a false. Whatever was coming from behind, I will return that itself, right? So this particularly states that if star acts as an empty string, I'll not be able to make any solution. Correct. Now this star will say, let us say that I'll consume this C as well. Let me consume this C as well. Okay. So let me consume this C as well. If this star consumes this C, right? So can I say that this star will still be on the hunt? You can say this C is consumed, remaining string is QD. But this star will still remain on the hunt. It will not get forgotten. The star will still remain on the hunt. I hope this particular case is clear to all of you. I'll write it a little bit like this. So I hope this is clear that this star is still on the hunt because it hunted C. It earlier hunted the B. Now it hunted the C, and now it will try to hunt Q itself. But before hunting Q, this star will say that, okay, let's do one thing, that I will try to come as an empty string. I will try to stop my hunt here itself. I hope you are able to understand this point of star when star is trying to act as an empty string, and they are the two main things. Why star is still persisting and why star acts as an empty string. Star is still persisting because star can essentially get converted into any form of string, right? Right. So we can definitely see here that star can act as an empty string. This is of course a valid thing which you might have understood. Here I am saying that star is consuming B, but I have not removed the star from here. Why? Because star can essentially convert into BC as well, right? Right now the star is representing a single B, which was matched earlier. Star is looking at, can I match with more characters? That's why star is remaining here itself. I hope this point is clear. And if star decides to act as an empty string, star is saying I will end my hunt here itself. And you can see I'm not able to make any answer. Let's see if star comes as an empty string. Star stops its hunt as an empty string here. Will it be able to make an answer? Let's assume this. Like, ध्यान से देखना. So star is saying that I'll come as an empty string. So remaining string will be as it is. and remaining pattern will be question mark D star because this star has been consumed. Let us explore this side of the tree now. Let us explore this tree, this particular thing. So question mark has no option but to match with Q. Okay, question mark says I will gladly match with Q, my friend. I will gladly match with Q. All right, let's see. Question mark is trying to get matched with Q. It has no option. Question mark has actually no option but to match with whatever character is in the front. So question mark does one call and question mark will say that my friend, I will try to match. I will try to match. Let's see what will happen. So star and Q we are having. Question mark and Q we are having. Both of these will be gone because question mark consumed Q. So remaining pattern and remaining strings will, the competition is between these now. Will this pattern be able to represent the string? We can, by the looks of it, we can definitely say that yes, we can represent this pattern into the string. But let us look at it in the test case itself. D and D. D is matching with D. So D will say gladly that can I able to match the remaining string? The remaining string is actually empty and the remaining pattern. Can I able to, like, am I able to match the empty string with star itself? If there is an empty string in the input itself, if there is an empty string in the input itself, star will simply say that, okay, I will act as an empty string. If the particular string, the input string is empty and we are having a star right here, star will not try to replace anything, like it will not try to consume anything. Star will do only a simple call. It will say that I'll act as an empty string. Can the remaining pattern match the remaining string? Right. So remaining pattern is nothing. So at this point you can see this becomes empty, string becomes empty, and the pattern also becomes empty. And when both of them become empty, this means that everybody was able to satisfy. So this will return a true from here. This returns a true. This returns a true. This particular returns a true from here. Whatever is getting returned from the front, I will return that itself. I will return true from here. I will return true from here. I will, as it is, return true from here. I got a true from him. I hope this is clear to everybody. This is the true which I got when star acted as a empty string at this particular stage. I hope this is clear to everybody and I hope it is clear, right? Let us try to call for the case when star will say that I'll not be acting as an empty string. I'll be consuming Q. Let's say I'll be consuming the Q. So if I'll be consuming Q, now here you will see a lot of edge cases, right? So full focus. I will try to consume this Q. So if star will try to consume this Q, the remaining string will become D and question mark D star. Actually, star will actually persist here because star consumed Q, star will look for more praise to consume, right? Okay. At this point of time, at this stage, at this particular stage, star will simply say what? Look at this stage only, right? Whatever stage I'm drawing on, look at this stage only. We're not concerned with the whole tree right now. I'll of course zoom out a little bit later. But star and D. Star will say, let's say, star always tries to act as an empty string initially. So star will say, let's say I'll act as an empty string. So remaining string will remain as it is. Question mark star D will be passed forward, right? Star is consumed because it is acting as an empty string now. Okay. So D question mark D star. Am I able to match the pattern? Question mark has no option but to match with this D. So the remaining pattern is the empty string is passed. Because of this D getting matched with question mark, the remaining string is empty string. And the remaining pattern is what? It is D star, my friend. D star. You can see my string has become empty. But this, you can say pattern, in the pattern, whatever characters I'm having in the front, it cannot represent an empty string, right? It is not empty and it is not a star as well. The first character only I'm talking about. This means that I'll not be able to match the string. I'm going to return a false from here. This is one of the base cases. So note this base case down. Note this base case down, right? So if the pattern becomes empty, the string becomes empty and pattern is having a non-star character in front. It can be a star as well. It can be a question mark as well. It can be a normal characters as well. So if the string becomes empty and the pattern is having a non-star character, there's no way I'll be able to make this empty string, right? If I'm having a non-star character. Okay. So this has no option but to return false, right? Okay. And here we get an answer that if star acts as an empty string, I'll not be able to match the string. Let's see if star consumes this D as well. What will happen? Full focus ke saath dekhna. So if this star consumes this D, star will still be on the hunt. This particular star will still be on the hunt. This D will be consumed and because of this star and it will become empty string. Now we are having a star in front and an empty string. Star has no option but to come as an empty string itself. So if star comes as an empty string, this empty string is passed along with the remaining pattern. This empty string is passed with the remaining pattern, and you can definitely see from here that we are having an empty string and a non-star character in front. Question mark cannot be replaced by empty string, my friend. So from here, I'm going to return a false. Whatever condition was this, it was like it is similar to this itself, right? I'm going to return a false from here. From here as well, I'm going to return a false as it is, right? And this in turn will remain whatever, like, was this particular pattern able to match the string? No, both of the conditions are false. I'm going to return false. Now you can definitely see question mark star question mark D star. Question mark can be replaced by Q, and D will be as it is. Both stars will be replaced by empty strings. True. This or this, I will return a true from here. I will return a true from here. I hope this is clear. I hope this is clear. CQD. If this star acts as a C, Q acts, question mark acts as a Q, D is as it is, and this star becomes empty string, I'll be able to match CQD. So can you see from here, I'm able to solve a smaller problem and I will return true from here. I know the recursion is a little bit typical in this question, but trust me, if you have understood this kind of pattern, you will remember this always. You will remember this always, right? Now you can definitely see that BCQD star Q star question mark D. If this star acts as BC, star acts as BC, and question mark acts as Q, D comes as it is, and this star acts as an empty string, I'll be able to match this string, right? I have to write a Q here and I have to write a D here, right? So this pattern will able to match the string. So or of both of these I will return true. This will return whatever the answer coming from, because A can only match A, it's having only one option. I'm going to return a true from here, and hence this is the whole recursive tree, right? And this is the whole solution for this problem itself. I hope this is clear to everybody, and I hope you got how we are doing the recursive thing in this problem. And yeah, let me generalize the solution itself and then move forward in the video itself. So let me generalize the solution itself, and the solution is like, I'll write a function recur, I'll pass string s, I'll pass string p, I'll pass I, and I'll pass j. I'll not actually break the strings. I'll not actually write, now I'm breaking the string now because of this test case. I'll not actually break the strings. I will keep two pointers I and j, which will be pointing on that particular ith character. So for example, here I and j both will be on 0. I and j both will be on 1 index. Here you can say I will be on 0, will stay on 1th index, j will be on 2th index, right? Because question mark is actually on 2th index in the pattern, right? So I and j, using this I and j, I'm going to represent. It is pretty similar to the last question we solved in this series. So this is a series which we are following. You have to follow it in order itself in order to understand everything. So recur s, p, I and j, this is the function I'm going to complete. Now the first base case is that if s dot length becomes equal to, like, if you can say, or I can say, if I is equal to s dot length, this means that I is finished, the string s is finished, and j is also equal to p dot length. Both of the strings are finished. This means that yes, empty string can be converted to an empty string, right? I'm going to return a true. Return a true. I hope this is clear. Else, what is the else case? If j, the pattern becomes empty, p dot length, and the string is not empty, right? Or we can, of course, I can write the same thing like this. If pattern becomes empty and the string remaining is not empty, I is not equal to s dot length, but j is equal to p dot length, I will simply say that empty pattern cannot represent any non-empty string, so I'm going to return a false. I hope these two base cases are clear. Now let's talk about some more cases, right? So one of the other cases is that, this particular case, which you talked about, this particular case, that the string has become empty, are we having a non-empty character in front, right? So non-star character in front. So if this is the next case, if I becomes equal to s dot length, this means that string s is finished, and j is not equal to s dot length, of course, and j is not equal to s dot length. This will be the case here. If we will simply say that if p of j is not equal to a star, it is a non-star character, it can be a question mark, it can be a normal character, I'm going to return a false from here as it is. I hope this is clear. Else I'm going to do what? I'm going to return, I'm simply going to return whatever, return whatever recur of S, P, I will be asked is J plus 1 will return me. Why have I written J plus 1? Because if P of J is, if the first character of the pattern is not a star, I'm going to return a false. But if it is a star, I'll go to this return statement, and here you can see this is the case when the jth character, the star, is acting as an empty string. That's why star is getting consumed. That's why J plus 1 is there. That's why I is remaining the same. J plus 1 is there. I hope this is clear to everybody. Here I will simply say that star is acting as empty character. I hope this is clear to everybody, right? Here the star is acting as an empty character. Okay, great. So this is the case. These are the cases whenever you can say I or J or anybody else can, you can say, come as a non-empty, you can say as an empty string, right? Any of them, right? These are some of the base cases, right? Let us look at some different cases. Let's just look at some different cases. What are those cases? If P of J comes out to be a question mark, the first character of pattern comes out to be a question mark. What am I going to return? What am I going to return? If this comes out to be a question mark, first character, question mark has no option but to match it whatever character the string S is having. And of course, by the time we reach this case, we always know that J and S will, like, both of them will be non-empty, because all these cases have been covered here, right? You can say that I equal to S dot length and J is not equal to S P dot length. This is the same case itself, right? So I can write like this: J is not equal to S dot length, P dot length, right? So this is the case when both of them are empty. This is the case when S is empty, P is not empty, right? This is the case when this is the case. Sorry, this is the case when S is not empty, P is empty. This is the case when S is empty and P is not empty. And by the time we reach this case, we definitely know that both of them are there. So if P of J is equal to question mark, the first character of P is equal to the question mark, I'm going to return what? I'm simply going to return this jth character will match the ith character in string. So I am going to return what? I am going to return, I'll simply write this statement. Let me reuse the things itself. I will simply write here, I will return I plus 1 j plus 1. I will return I plus 1 j plus 1. Why am I doing I plus 1? Because question mark is getting matched with, you can say, this question mark will be this P of jth character will be matched with question mark. I'll show you in the recursion tree. Look at this. So when we were always on a question mark, you can see here we are on a question mark in J. This is the I, this is the J. Can you see? This question mark will match with B. So remaining strings from I is I plus 1 onwards. Remaining string from J from P is J plus 1 onwards. So I plus 1 J plus 1 will be called from here. Whatever that gives me, that will be my answer if I am a question mark, right? Now else if P of J is equal to a star. In the pattern, if we are having a star as the first character, so star always do two things. Star always does two things. Star will try to act as an empty string. Star will also try to act as to consume a character. So I'll simply do that. Like, I'll simply say here that if star acts as an empty string, empty, star whenever acts as an empty string, we are going to do the same call here. This will give me a boolean value, whatever the result, whether when the star acts as an empty string. You can see I is remaining as it is, J is getting consumed because star has decided, this P of jth character, which is a star, has decided to act as an empty string. I hope this is clear. And if it comes, if it consume, I am going to recur for I plus 1j. I am going to recur for I plus 1j because this plus 1 will go here. I hope this is clear to everybody. Why I plus 1j? Look at this. When this star decided to consume this C, it is remaining as it is because it will hunt for more praise. But C is getting consumed. So Q onwards, the remaining string is Q onwards. Remaining pattern is still star onwards. So J will remain as it is. I will be incremented. I hope this is clear to everybody. What will we return in this from this case? We will simply return empty or consume. I hope this is clear. Empty or consume, right? Whatever gives me true, I will return that true itself, right? And you can see definitely P of j can be a question mark, P of j can be a star, P of j can also be a normal character, right? P of j can also be a normal character. So if P of j can be a normal character as well, what am I going to return from here? I will first check, you can say that P of j can act as a character. You can see from here, from this particular case. If the characters are not equal, I'm directly going to return a false. But if the characters are equal, you can see in this kind of case, let me find out that case. In this particular case, you can see, okay, look at this. In this case, when the characters are equal, I'm going to do what? When the characters are equal in this A and A, you can see the characters are equal. I'm going to search for the remaining string. So the case is that if S of I is not equal to P of J, if the characters are not equal, of course characters, the P of j is not a question mark, not a star, we are not replacing it with anything. And if it is not equal to s of I, if it is a character, it has to match with the ith character. If it is not equal, I'm going to return a false. And if it is equal, I'm going to simply return whatever the remaining strings are. It will actually act as a question mark in a way, we can say as well, right? So whatever, because ith character was able to match the jth character in the pattern itself, so remaining answer will be found for all the people after it. Recursion is a little bit typical, many if statements are there, but I hope this is clear. These are the base cases we are having. Then we are checking if we are question mark, we are star, or we are a normal character. I hope this is clear to everybody. I hope you are able to understand what we actually did in this problem. I hope you understood the whole recursive tree. Videos are, again, I'm saying that videos are a little bit long, but it will give you the deep in-depth insight of the problem itself. It is a guarantee that if you watch this video, if you watch any of my videos in DP series, you will not be missing anything from the concept of the problem itself, right? Let us quickly write the recursive code and then look at the memoization code itself. So we are here with the problem statement itself, wildcard pattern matching. Let us quickly start writing the code itself. I will write a function called public boolean recur, right? String s, string p, string p, int I, integer j. These are some of the parameters I want to pass. I hope this is clear. I'll just remove this from here. Okay, clear. Chalo. Now I can be equal to, let me do one thing, integer s dot, or let's do it simple way only. If I is equal to s dot length and j is equal to p dot length, both of the strings have become empty. I will return a true from here. Both of the strings have become empty. Both have become empty, right? I'll write the comments here. Both empty. I'm going to return a true in this particular case. Now the case arises if I is not equal to s dot length, we are having some characters in the pattern, but j is equal to p dot length. Pattern has become empty. I'm going to return false. String is not empty. Isn't empty, but pattern is no more there. Pattern is no more. So I'm going to return false. How can you match an empty pattern with a string which is having non-empty characters, right? So I'm going to return a false from this case. Now let's move forward. In this particular case, I is equal to s dot length. I can become empty. S can become, the string s can become empty, and j is not equal to p dot length. What am I going to do? I will write as clean code as possible. I'll not use any shortcuts here, right? You can of course do this in less number of if else statements, less number of if else check, but I want to like state this as clearly as possible. That's why I write the code like this, right? If I is equal to s dot length and j is not equal to p dot length, which means that if we are having something in the pattern and that something p dot char j is a non-star character, this means that we cannot replace this with an empty string. S has become empty. We cannot replace the non-star character with an empty string. I'm going to return a false from here. And if there is a star there, if there is a star I'm having here, I'm simply going to return recur for S P I j plus 1, because star will act as empty string. I hope this is clear to all of you. Clear. Let's move forward. So these are all the base cases, I must say. The base cases are over. Let us look at some normal cases, right? If pattern dot char at I is equal to a question mark. If we are equal to question mark, we have no option. Sorry, p dot caret j I should write here. If p dot caret j is equal to question mark, I have no option but to match with the s of ith string. So I will return for I will return whatever the answer is from recur s p I plus 1 j plus 1. I have no option but to match. Else if p dot caret j is equal to a star, if we are a star, right? If we are a star, what will happen? I will simply say that boolean, if this particular character comes as an empty string, right? If this star acts as an empty string, empty, recur for empty star. I'll write here empty star, right? Okay. So I'll recur for what? Whenever star acts as an empty string, this is what we do. We will call whenever star acts as an empty string. Boolean, you can say consume. If this particular star consumes the ith character, recur for, because star can be replaced by anything else, right? S, P, I plus 1, J. Star has consumed this particular vector. I am going to return empty string, empty star or consume. I hope this is clear to everybody. These are all the conditions when I am a star. I am not a question mark. I am not a star. This means that I am a empty. I'm a non. You can say I'm a normal character, right? And if I am a normal character, if I am a normal character, I have no option but to. I have only one option, which is to match, right? So if s dot char at I is not equal to p dot char at j, s dot char at I is not equal to p dot char at j, what will happen? If s dot char at I is not equal to p dot char at j, I am simply going to return false from here. That I'll not be able to make a string. Else I will simply return. I'll simply act as a question mark. I have successfully matched with the first character. So whatever is remaining from both the strings, you can see this question mark case, whatever is remaining from both the strings, I'm going to return that itself as it is, right? This is the whole recursive code. Let me write return recur here. SP I'll pass 0, 0 I'll pass, and yeah, let's run the code and let's see if it's passing the base cases. You can say the sample cases itself. So time limit exceeded. Definitely, I have actually introduced some extra cases. Let me reduce these extra cases. Let us look at some small case itself, because of course this is a recursive code. It will definitely give me a TLE, right? But the sample cases it is passing with flying colors, right? And these are the sample cases. That was some extra case I added in order to verify the code itself. All right. So I hope this is clear to everybody. I hope you have fully understood the recursive code. We are going to write the memoization code after this. Tabulation I'm not going to cover in this particular video, because tabulation is just using a trick itself, the trick we have talked about in all the videos previously to this, right? This is the DP series which we are following. I'm sharing some very important tricks to convert recursion to memoization, tabulation, and so on. So if you are directly watching this video, I advise you to watch the whole previous videos in this playlist, because everything is interlinked right now, correct? At this point we are following DP with strings, right? So you should definitely watch all those problems before and try to develop insight on converting memoization to tabulation itself, right? So in this particular problem I'm going to cover recursion and memoization. Tabulation is of course using a trick itself, so that is just some extra, you can say, time itself. You can of course try it out on your own, or you can of course comment that down. You can say comment the tabulation code below as well. If once you have completed, I can definitely verify that as well, right? So also we are having a Discord community. You can join that Discord community where students ask their doubts. I'm also planning to do some activities there very soon, as soon as the participant count increases there. But yeah, so let us look at the memoization code quickly and then wind up the video itself. So to convert this recursive code to memoization code, we will follow the simple trick we talked about in all the previous lectures. I will copy this. I will paste this here. Why we are doing this trick? Why will this trick work? I've already covered in the previous lectures, right? You can say from this playlist itself, you will see somewhere around here, you will see the I button. You can of course click that and you can of course join in the playlist itself, right? So let's move forward. After copying this, you can say recur function, wherever recur is written here, in this function, I will replace it with memo. I will basically change the function name. Now memoization function involves recall and remember strategy, and for that I need some extra space. I need to take some extra space, and that space will be consumed as in the form of a DP array, and that will be a 2D array. Because why 2 dimensions? Because I and j are the two parameters which are getting changed. So two parameters are getting changed, so DP will be of 2D, right? Okay. And we have to return a boolean here, but I am considering this as integer, right? Because in this DP array, I will say that if DP of I comma j, if I will say simply, if DP of I comma j, if DP of I comma j is equal to -1, this means that it means that it's false. If DP of I comma j is equal to 0, if it is equal to 0, then I will say that I have not calculated the answer for I comma j. And if the DP of I comma j is equal to 1, this means that I have calculated the answer and the answer have come out to be true. So I hope you are able to understand that why I am taking an integer DP here, just to keep the states intact. And the states are, if I have calculated the answer before or not, and if I have not calculated the answer, I will calculate the answer, recall and remember. I hope you remember that. If I have calculated the answer and there's a -1, this means that I've calculated false. If I've calculated the answer, this means that there's a 1, like there's a non-zero element, and if there's a 1, this means that I've calculated a true answer, right? So I will simply write here wherever I am calling this memo function, in all these, you can say, places I'm calling the memo function, I will simply say that, here also I'm calling. So I will pass this DP array here at all these places, right? Because of course there's a function definition, I have to satisfy the function definition as well. The code is becoming a little bit hotchpotch, but I hope you are all able to, like, you can say, understand what we are doing. Just some simple iterations. So wherever I'm writing recur, I'll simply, you can say, add a DP array in that. So I hope everywhere I have added the DP array. Now the only thing is recall and remember. So after the base cases, right? After the base cases, let me do one thing. Here itself. If DP of I comma j is not equal to, if it is not equal to 0, this means that I have calculated the answer before, and I will return, if you can say DP of I comma j is equal to 1, I will return a true, else I will return a false, return false. Correct? If DP of I comma j is 1, this means that I have calculated true, else I'll return false. Instead of writing this if else statement, I can also write it like this: return DP of I comma j is equal to 1. If this boolean expression comes out to be true, I will return true, else I will return false. I can simply, instead of writing those if else conditions, I can write in this way as well, right? I hope this is clear. This is the recall statement. Recall, right? Recall. And remember we always do whenever I'm, you can say, returning something, right? So here, after, you can say, before calling here, right, I will simply say DP of I comma j is equal to, if this particular recursion call returns me a true, I will store a 1 in DP array. If this returns a true, I will store a 1, else I will store a -1. In the end, I'm going to return if DP of I comma j is equal to 1 or not. I hope this is clear here. This is a ternary operator I've used many times, I've used in the previous videos. If this particular call returns a true, DP will store 1, else it will store -1. And we are returning if DP is 1 or not. If it is 1, this means that we got a true from here. So I will return this expression will evaluate to true, else it will evaluate to false itself. This same thing I'll do everywhere. So here also, if DP of I comma j is equal to, if this particular recursion call comes out to be true, I will store 1, else I will store -1. And in the end, I'm going to return DP of I comma j is equal to 1. I hope this is clear. Here you can definitely see that DP of I comma j is equal to 2. If any of them comes out to be true, if this particular expression comes out to be true, this empty star or consume comes out to be true, I'm going to store a 1 in DP of I comma j, else I'm going to store a -1. And in the end, I'm going to return DP of I comma j is equal to 1. Right? I can of course return this as well, definitely, but I am doing it as a standard everywhere, right? So all right, in this particular case, we can directly return false from here. We don't have to do a lot of things. Actually, we are directly returning false, so it is acting as a base case, I can say. We don't need to write anything here. Wherever we are doing a memoization call, there I want to remember the answer. So DP of I comma j is equal to what? If this memoization comes out to be true, store 1, else store -1, return dp of I comma j is equal to 1. I hope all of this stuff is clear. Memoization function is finally complete. It was a little bit typical, but definitely integer dp is equal to new integer s dot length +1. I'm adding a +1 just to do some safekeeping, right? Just some extra indexes I'm taking so that I can avoid, you can say, some integer out of bounds if there will be any, right? I'll simply return memo of s comma p comma 0 comma 0 comma dp. I will pass all these parameters here. I hope this whole thing is clear to everybody. Why we are using the dp array, recall and remember wherever we are remembering the solution. I hope that is also clear to you all. Let us run the code. Let us see if it's working or not. It's working just fine. Let's try to submit this and see if it gets passed. So it's passing with flying colors, and yeah, I hope this particular thing is clear. You can definitely convert this memoization to tabulation as well, just using the trick I taught. It will be a little bit challenging thing to do, but it will be a fun activity for you all as well, right? So try to convert this memoization to tabulation. Do tell me in the comments whether you were able to do it or not, and if you were able to do it, just paste the code right directly in the comment section itself, right? So I hope you enjoyed this lecture. Wildcard pattern matching is a very interesting problem, and the recursion is very, you can say, unique kind of thing, right? So I hope you enjoyed this lecture itself. If you are enjoying the lectures, please like, share and subscribe the channel. Please show some support. You can definitely tell me in the comment section how you're liking the videos or not. In the end of every video, I am displaying the highlighted contents, and to all the people whose comments are getting highlighted, thanks a lot for all the support you all are giving me. We're so close to 500 subscribers, and yeah, we are soon going to, like, this DP, we have almost covered more than half of this DP playlist. So thanks a lot everybody for, you can say, tuning in this video as well. Until the next video drops, bye.